Hello and welcome to Spy Math. This is Mr. Spy and this is the final video of my series of logarithms on solving exponential equations in real life similar equations. First case would be a case of half-life. First example, we have 20,000 times 0.5 to the x over 35 equals 5,000. You want to get the part I highlighted alone, and that part tells you that's a half-life equation because it rates 0.5. So you divide both sides by 20,000. Get 0.5 to the x over 35 equals 0.25. Use log of base 0.5 of 0.25 equals x over 35. Multiply both sides by 35. Plug this into the calculator. So you plug 35 times log of 0.5 of 0.25 into the calculator, and you get approximately, actually in this case you get an exact answer. I'm not going to explain why I know that, but you get an exact answer. So 35 times alpha window option 5 of 0.5 to the 0.25. You get exactly 70. And the way I knew this was going to be an exact value was if you check on the calculator 0.5 to the 70th power and you multiply that by 35, oops, sorry, 0.5, you want to check your answer because you got 70. It's really interesting. So you do 35, which is your power. So you have log alpha window of 0.5 to the 70th power. So that is your power. It's hard to check this. Divided by 35. Get 0.25. And it's the same thing as 0.5 raised to the second power. 75 by 5, 35 is 2. On to the next question. Okay. First thing, you simplify what's inside the parentheses. In this case, 400 times 1 plus 0.18 over 4 to t equals 40,000. A simple case of compound interest, usually quarterly because we're dividing by 4, the rate of 18, increasing. So we first simplify what's inside the parentheses. So 1 plus alpha y equals together fraction 0.18 over 4. And you get 1.045. So you rewrite our equation. 400 times 1.045 to the t equals 40,000. Divide both sides by 400. Get 1.045 to the t equals 100. Use log to rearrange it. So you have log of base 1.045 of 100 is our answer, which is approximately, so alpha window log of base 1.045 of 100. It's approximately 104.623. 104.623. Okay. If you want to check your results, you can. I'll go over that in a different example. writing that neatly for some reason. 4.623. If you want to check that, you could type everything into the calculator. So alpha, window, option 5, log everything in the base is equals to 1 plus alpha y equals our fraction, 0.18 divided by 4, close that parentheses, put inside here 40,000 divided by 400, and you get the same exact thing. Calculator do everything for you in these cases. Just got to set it up correctly. On to 2 natural log cases. Or you could use natural log. We have 3x equals the natural log of 5. And you divide both sides by 3, and you get natural log of 5 divided by 3. You get the exact same value of 0.536, and you do. So there's always multiple ways solving this equation. On to the last case, and then we'll use one case where we'll show you how to use a graph. So this example, we'll use natural log completely. It's jumping around. Don't let that happen. So you want to get the e part alone. So you have 20 times e to the negative 0.5x minus 70 equals 5. You add 70 on both sides. You have 20 e to the negative 0.5x equals 75. Divide by 20. You have e to negative 0.05x equals 75 divided by 20, which is 3.75. Use natural logs. So you have a natural log of 3.75 equals negative 0.5x. Divide by negative 0.5. And you get x is approximately natural log of 3.75 divided by negative 0.05, and x is negative 26.43. Negative 26.43. On to the last case, before we do an example of a logarithm solving. We're going to use a calculator to solve this. It's a challenging algebraic example, because if you notice, the bases are not the same. So before we use a calculator, let's look at before you do algebra, let's look at the calculator's answer. So you type in the first equation, 200, 1.6 to the x, and 400, 1.2 to the x, and we're going to have to see where the 2 intercepts. Let's do its typical window. Do the standard. We have one graph. Blue, only one graph is graphing. It's interesting. Still loading. Turn it back on. Something weird happened there. Say they're both incorrectly. Okay. You don't even see both graphs, because you know graphing doesn't help much either in this case. So it's good to start off with algebraic to clean up a bit. So we divide both sides by 200. Divide both sides by 200. We have 1.6 to the x equals 2 times 1.2 to the x. Now, we want to rearrange this. We have to use, can't use log base in this case because the bases are not the same. We take the log of both sides. So you have x log of 1.6 equals x log of 2 times 1.2. Scroll up. X log of 1.6 equals x log of 2 times 1.2, 2.4. Now, you think, x times log of 1.6 is x log of 2.4. Really can't be, because there'll be two different values for x, and that's equal to each other. So you really can't do this algebraically either. So you really are in a bind very often when you'll notice you have two equations that look like this. So the easy way to do it is by looking at a tabular result. So if you look at our equations, 201.6 to the x, 401.2 to the x, you look at the table, both equations, you start seeing, is there a place where the two are sort of the same? So you start your table at 0, and you look at your table, and you start at 200, 400, then you see 320, 480, 512, so 6, 8, 9, 12, 8, 11, 13, 10, 8, 92, 20, 335, 858, after 10, after 11, you'll notice that the first one exceeds the second one. So x is approximately 11. Now, there is a way to solve this algebraically. I'm not going to go over how to do it. If you're interested in how to see how to solve this algebraically and to prevent the problem that I just showed you happening, if you don't know how to do it correctly, and to use the graph or not use table somewhere around 10, 11 years, we see this value starts being greater than this value over here. Here's 2199.0. Here's 2476, 13744, 263. So it's somewhere around 9 to 10 years, maybe 11 years. And that's what we can look at. Now, one more example. What happens if they ask you to solve for x inside a logarithm? Say it's something like this, log of x plus 2 minus 3 equals 10. And let's say it's log of base 3. Okay? So you can rewrite this using 3 to the 10th power after you added 3 on both sides. Don't forget to do that first, because you want to have the log by itself. So we have the 13th power instead of the 10th power. So 3 to the 13th power equals x plus 2. You do 3 to the 13th power, and you calculate a gigantic number. So it's 159,433 equals x plus 2. Subtract 2 from your result, and you get x. It's approximately 159,43321. Okay? And And that's it for my series on logarithms. If you'd like to see how to more solving logarithms by using graphing, or by, for example, see how to do it accurately algebraically, which do not ask you to do in Algebra 2. They always expect you to use a table or a graph to solve those type of equations. Or if you'd like to see a video on any other topic in Algebra 1, Geometry, Algebra 2, AP Calculus, AP Statistics, or SAT Math, or any other topic in high school or college mathematics, please leave a comment below. Like this video or any of the other 4 videos in this series. This is Mr. Spy, signing off.